Adir. Today we are going to go really deep into source maps. It sounds scary, but I promise you that by the end of this presentation, you are all going to understand what source maps are and how they really work. How many of you, by the way, know roughly even what source maps are? Great, the majority of you. So let's start. My name is Adir. I'm part of the developer tools team at Wix. I've been building for the web for quite some time, and I really like JavaScript infra and tooling, and that's why I'm talking about it today. So in this short session, we are going to really talk just a little bit about the problem to make sure we are all aligned about why we need source maps. Then we are going to understand what source maps are, and then we are going to see how they work. So let's dive right into it. Here I'm going to go over a simple application. You don't need to understand exactly the code, just making the point to see why we need source maps. So let's start. Let's write a simple Node.js script. I have this script. I hope this is big enough. Basically, a small Node.js script that gets a string and say hello to this string. And if I run it, it says hello to the string. Let's see how this is implemented. A basic Node.js script. The class gets the name and then print it to the user. This is super simple, so let's complicate it a little bit, again, just to demo, to see why we need source maps. The code is not that important. So we have this script, then we extract some logic to a different function, and we complicate it. Here we have some validation. We'll come back to it in a minute. We validate the parameters. Then, since we have some code, we separate it to several files. And now we need to run it. This was written in TypeScript, and Node.js currently cannot run TypeScript, so let's transpile it. This is the JavaScript code. This is TypeScript, this is now JavaScript. Now let's also bundle it, just for reasons. So we bundle it, and we have now a single file. We started with 3 files, now we have a single file. And let's also minify it because of reasons, just again to understand how source maps help us. So this is the code we end up with. And now let's run it. I'm running it with my full name, and this is all good. And now let's run it again with my short name, and it will throw an error. And this is important because this error is not very convenient, right? You can see in this error that the stack trace is not really useful. This is a bunch of code that I didn't really write. This is what Babel, or the generation process, basically generated for us. Also, the file paths are not really correct. They all point to the generated file and not what I wrote. So this is not very convenient, but let's make it convenient. This is why we need source maps. So let's do it with source maps. To enable source maps, we add this simple annotation or comment to the end of the generated file. Build tools they do it for us. So we have this small comment, and now we run it again. I give it my full name. This is the full name and it works. This is only my first name, and now I get an error again, but this is something I can work with, right? Because we can see this is the code that I actually wrote. I can see the path. This is the actual file that I wrote, the TypeScript file that I see. I know what it is because I did it. And also the trace is actually correct. So source maps basically allow us to debug or understand transformed code, and they map exceptions to the original code. So let's see what they are. And basically, the specification for source maps is just a Google Doc. It might surprise some of you, but this is a Google Doc. It's less than 10 pages. And this is all the spec for source maps that there is on the internet. This is the formal spec. This is not really formal, but we'll talk about it later. This is the spec for source maps, a Google Doc. You can Google it. Search for source map proposal, you will get to this document, and this is basically the spec for source maps. And in order to understand source maps, we need to understand some terminology. So let's clarify it. In source maps, we have the original code, which is the code that we wrote originally. For example, the TypeScript code that I showed initially. And we have the generated code, which is the code that compilers or transpilers generated for us. And source maps, basically, they map back generated code to original code. Super simple. The transpilers map original code to generated code, and source maps map it back. So this is super simple, and let's go with a simpler example now, and let's see how the mappings are actually working. So this is a simple version of the hello thing. So I have a function, it gets two arguments and say hello to whatever it got. And then we pass it through Babel. Babel is an old build tool, but let's stick to it. I'm using Babel to transform my code, to bundle it, and to generate source maps. So I run it through Babel, and then I get two new files, the original file, and then the generated file, and a source map. Let's look at them. This is the original file. This is the generated file. Same logic, but the syntax is a bit different. And those are the source maps. Let me move my cursor maybe. I see it's in the middle of the screen. Oh, you don't see it actually. And those are the source map. And now let's dive into the source map and understand how it works. So the first field in the source map basically states the version or revision of the source map protocol basically. And we are using currently version 3. So this is version 3 of source maps. Then we have the generated file. This is the generated file. Then the sources field basically represents the sources that were used to generate this generated file. In this example, we have a single source, but in the original example, I had 3, right? I had 3 files and I bundled them. So it could have several fields in the sources array. And then we have the sources content. Sometimes it is useful to actually embed the source content in the source map file itself. We will not talk about why, but you can figure it out later. And names is also useful. We will not dive into it, but basically names allow us to map symbols. Symbols is, for example, if you, again, minify code, you sometimes rename variables. You have a variable with a long name, and then it becomes something like A, B, 3, right? And those mappings are basically stored in the names list. And we have the mappings. The mapping is basically the heart of source maps. This is where all the magic happens. So let's demystify it. And in order to understand mappings, all we need to understand are 4 super simple things. The first thing is that mappings start at the beginning of the generated file. We'll see it in several minutes. The mappings, each semicolon in the mapping basically represent a line break. We'll see it live. Each segment is a base 64 VLQ. We'll talk about VLQs. And each segment, basically segments, are separated by a comma. So let's let's make sure we understand it. So basically, do you see it? So basically in these mappings, we start with 2 line breaks. Those are 2 semicolons. Then we have a segment, a comma, another segment, comma, another segment, and simple, right? So let's recap and then dive into it. So source maps, it's basically just a single JSON object. It maps generated code to original code. It can be referenced with either a comment which we saw or an HTTP header. This is also possible. It uses VLQ to reduce the file size. It is widely adopted. Every build tool, transpiler, browser, runtime, whatever supports source maps. And also, we usually see source maps in the JavaScript or front-end context. This is not specific to JavaScript. This is an agnostic protocol that can be used anywhere to map one thing to something else. Also, this is used mainly in JavaScript. Cool. So I hope it was fairly simple by now. So let's dive in and understand how those mappings work. So VLQ, I will not talk about the formal. We don't have enough time. So let's dive into to the actual, how it works. So VLQ, we basically transform one value to something else. In this example, the letter A in VLQ is basically the number 0 and everything else. And the last 2 lines might be more familiar to you because this is the format that we also have in the source map file. And you can see that this is a bit longer, basically a list of 4 items. And let's dive into those items. Here I decode several examples of my source map, but now let's dive into those segments. And it might be like a list of numbers, but each one of them has a meaning. And it's super simple again. The first field basically represents the column index in the generated file. We said we map one file to something else, so we map them by indexes. The first field is the column in the generated file. This is the only field that references the generated file. And now we reference the source file. So the second field is the source we are talking about. In the previous example, we had a single source, so it's going to be 0 throughout all the mappings. The third field is the index of the line in the source, and the fourth field is the index of the column, which is basically the character in the generated file. It might be a bit vague, so we will see it live and it will be super clear. And the third thing, the second thing you need to understand about segments is that they are relative. What does it mean? So the first segment is basically relative to itself, so it stays as is. The second segment stays as is also, but this is accidental. This is only because the first one was all zeros. So let's see the first one. The first one was all tens, and then it became something else. Now, how was this calculated? Super simple. Up until now, we had here 4, right? This is 4, this is 10. So this is 4 plus 10, simple. 6 plus 10, simple. So basically, we add up the previous segment to the current one in order to calculate the absolute mapping. And a fun fact, the reason this is relative is also to save space. It is usually shorter to store like relative positions instead of the absolute ones, because we tend to have long files when we code, and this is what the last mapping became. So let's transform the original mappings to the new ones, and this is the absolute mappings. And now let's recap everything. This was the original file. You can see it at the top left. This is the generated file. Those are those mappings. And we talked, I said to you, like columns, indexes, stuff, and it might not be super clear, but this is going to be super clear now. So let's see a nice visualization. This is basically a website that I uploaded my generated code to it and my source map. And let's focus first at the bottom here. You can see I have 0. Let's focus on the first and last numbers. So 0, 0, 4, 6. Let's go back to the source map. 0, 0, 4, 6. 14, 16. Let's go here. 14, 16. This is basically the same file, right? So we did all the calculations. We made the relative segments absolute. We ended up with an absolute list of mappings. And this file allows us to visualize the mappings. So let's see. The first mapping basically maps var to const. Now, how does it work? Let's go back to the code. This mapping was all zeros, right? First of all, let's start with the line breaks, actually. We started with 2 line breaks. What does it mean? It means that my generated file has 2 lines that do not exist in the original file. And why is that? Because Babel generated them for me. I didn't write this use strict. I don't have it in my code, so there's nothing to be mapped to it. So those 2 lines have no mappings. And then we end up in the third line. The third line, the first column there is mapped to the first column in the original file. It's a 0-based indexes. So the first line and the first column. So basically, the start of the var here is the start of the const. Now let's go to the next mapping. We have 4, so let's calculate 4 characters. We have 1, 2, 3, 4. This is right before the greeter. So the 4th character is mapped to the 6th character, which is before the greeter here. And this is basically mapped var to const, because the distance between those 2 segments is exactly, here it is var, here it is const. Let's continue. We have 14, 16. I will not measure it, but basically 14 is here, 16 is here, and this is how we mapped this, the word greeter. And let's go back to this example. So var is mapped to const, and this is the mapping. Greeter is greeter. This function is this anonymous function. And I can also go from here. First name became 2 different things in the original file, in generated file. but you can see source maps can reflect that. Last, everything super simple, it works. I have another visualization, so you can see it here with errors, but basically the same thing. And you remember in the beginning I told you that all we have for the source map spec is a Google Doc. So this is no longer the case, so will change soon, because now it's going to be standardized. TC39 are going to have a formal standard for source map. They are working on it. We have a formal spec, and that's pretty much all. Thank you, guys. I hope you learned something new.